Alright, so we got rickets here. Vitamin D, whether ingested as a dietary supplement or produced naturally when sunlight falls upon the skin, is essential for strong, healthy bones. The bone disease rickets was largely eliminated in England during the 1950s, but now there is concern that a generation of children more likely to watch TV or play computer games than spend time outdoors is at increased risk. A recent study of 2,700 children randomly selected from all parts of England found 20% of them deficient in vitamin D. So we have to find a 95% confidence interval, explain carefully what our interval means, and then explain what 98% confidence means. Okay? Alright, so, sorry, 98% confidence interval. Okay, so let's do it. So here we go. So what is the proportion now? Well, it's the proportion of children in England that are deficient in vitamin D. Okay, assumptions and conditions. Okay, 10%. So 2,700 children is less than 10% of all children. Okay, random. So sample was randomly taken. Independent. Each child's vitamin D level is likely to be independent. Success failure. So let's do NP hat. NQ hat, and let's see what we got here. So NP hat, 2,700 times 0.2, and that's 540, and that's greater than 10. 2,700 times 0.8, that equals 2,160. That's greater than 10. So we're good to go. Let me zoom this out a little bit. There you go. So you got all four conditions met in the test. One prop confidence interval. Okay. Where N is 2,700, P hat is 0.2, Q hat is 0.8. The interval, confidence interval equals P hat plus or minus Z times the square root of P hat Q hat over N. So that's 0.2 plus or minus. Now let's talk about the Z, okay? We're doing 98% confidence interval. Okay, so that means we're going to shade in the middle 98%. So how much is left? Well, 2%. Well, 2% has to be equally divided into each tail. So that must mean there's 1% here and 1% here. So that means that this must start at the first percentile and end at the 99th percentile. So we got to find that z-score. Okay, so we're going to say, okay, calculator, we're going to do inverse norm. You're going to say, okay, give me the 99th percentile, and you're going to get 2.33. Okay, so if you do the first percentile, the 0.01, you're going to get negative 0.233. It's the same thing. So z here is going to be 2.33 times the square root of 0.2 times 0.8 over 2,700. Then we're going to go, and we're going to go to the calculator, and we're going to go to stat test. We're going to go to 1 prop z int, and x is 0.2 times 2,700, and it has to be a whole number. It is 540. And then n is 2,700. Confidence level is 0.98, and we're going to calculate. So we get between between 18 and 22%. Okay? So what does that mean? So this is really our answer to B. So we are 98% confident that
Bill Newton, when you get there, stop by the main office. Bill Newton, no rush.
18% and 22% of all children in England are deficient in vitamin D. So that's your answer to B. And then the answer to C is really, what does a 98% confidence mean? And that means if we were to take multiple samples of the same size, okay, of 2,700, 98% of them will contain the true proportion of children deficient in vitamin D. You know, so if we take 1,000 samples, we expect 98% of them. If we take 1,000 samples of 2,700 and they're random, we expect 98% of them to contain the true proportion of children that are deficient in vitamin D.